All right, we're going to look at logarithms here, and we're going to start with just a little definition of logarithms, then we're going to give a brief introduction to solving log equations. This is a big topic that we'll cover more in subsequent videos, but for now, we're just going to get the tip of the iceberg. So logarithms answer the question, what exponent do we need for one number to become another number? And so the example I gave is I said 3 squared equals 9, okay? Or in other words, you could say 3 to what power is 9? And if you don't know that, that one's pretty easy for us, and it's an easy example, but what we can do is if we don't know that, we can use the idea of logs. Like I say, log base 3 of 9 is x, or in this case, it's 2, okay? And so I kind of give that example there. Once again, it's easy here, but think about this. What if we had a more complicated situation where I said 3 to what power is 22.6? You'd say, oh shoot, I don't know. 3 squared is 9, 3 to the third is 27, but what number would give you a 22.6? And then you could use a log. You say log base 3 of 22.6 equals x. And this would be something we could put into our calculator, okay? And so what I'm trying to show here is there's this way of writing a log. If you're given something in exponential form, you can rewrite it in logarithmic form. And I want you to write this down. This is an important little transition in your notes. This over here is called the exponential form. And this over on the right is called the logarithmic form. Okay? And just notice how the little switcheroo goes. This number right here is your base, so it becomes the base. This number up here that's your exponent is kind of like your answer, because remember, we're trying to find what the exponent was. And this number over here is your argument. It goes there. Okay? So write this down, know it, memorize it, love it, and let's see how we can use it. So what we're doing is we're solving these equations, these log equations. See how we have 3 equations? We're going to solve all 3 of them. Using really this property right here is going to get us there. So if I know that log base x of 8 over 27 equals 3, we are currently in log form, right? And so what we're going to do is let's rewrite an exponential form and see what happens. So this number that is the base becomes the base for the exponent. So I'm going to rewrite this. It's going to become x to the third equals 8 over 27. Hopefully you see how I just took this form and flipped it around to make it in this form. Now that we're here, we can solve this equation. I'm going to take the cube root of each side, and I get x equals 2 thirds. By rewriting this log in exponential form, by using this knowledge, we can actually solve and figure out what x is. Okay, let's come over here. Once again, I'm going to rewrite this logarithmic form into exponential form. So it's going to be 4 to the 5 halves equals x. Okay, great thing about this is there's nothing you really solve. I can just take 4 to the 5 halves and punch it into my calculator. And what that's going to become is that's going to give us a 32. That's the solution to that equation. Let's look at our last one. Same song, different verse. I'm going to start by taking this logarithmic form. I'm going to rewrite it in exponential form. So this number becomes my base, over 49. This number becomes my exponent. And that's going to be equal to the cube root of 7. Now, what we have is we have an equation here we're trying to solve. And this one requires a little bit more ingenuity to solve. What I'm going to do, since I have basically an equation involving exponents, is let's rewrite both of our bases as the same base. Meaning, the cube root of 7 is the same thing as 7 to the 1/3 power. 49 is the same thing as 7 squared. And now that since I've written both sides of my equation with the same base, we know that 7 to some power equals 7 to some power, so those powers must be equal. In other words, 2 times x must be equal to 1/3. So if I divide by 2 on each side, we get that our solution there is x equals 1/6.